Okay, so let's pick up where we left off, which was looking at the mode. We just got done looking at the mean and the median. So now the mode is the next measure of central tendency, or measure of center. So the mode of a data set is the value that occurs with the greatest frequency. So that's pretty cut and dry. Now, there are some different cases of modes that we could have. So we could have one mode, we could have more than one mode, or we could have no mode. So now the more than one mode and no mode, those are kind of linked together. Now, as far as what's the more than one mode possibilities we could have, well, really, it varies depending on the textbook. So some textbooks will say that you could have a multi-mode, so to have lots and lots of modes. But most books will say that the most that they will recognize is two. So two modes, which is considered bimodal. So sort of like a bicycle, bimodal. Now, what happens if there's more than two? Well, in those cases, the same textbooks would say that there's no mode. So if it looks like there's three modes or four modes, then there's no mode. So we'll try to hit some of those scenarios. And if we don't have enough, then definitely ask some questions. All right, so let's find the mode here. Now, if we look for some repetition, that's the big thing. We want numbers that repeat. And in this case, I'm not seeing any repetition in any of those numbers. So if there's no repetition, there's no mode. Done. All right, what about this one? Well, so we do have a little bit of repetition. We got 23.5 that happens twice. And do we have anything else? Doesn't look like it. So in this case, we do have one mode. So the mode would be equal to 23.5. So not anything too drastic, but like I said, depending on the situations, you got to be a little bit careful. So, all right, let's try. We're going to come back to that, more examples in a minute, but let's jump to the last measure of central tendency, a measure of center. So you're probably saying, well, wait a minute, I know mean, median, mode. There's more? Well, yes, there is. The mid-range is another measure of center, and it's found by the value that's halfway between the maximum and the minimum values in the data set. So you're kind of averaging the extremes and seeing what the middle is based off just those two numbers. So in this case, the mid-range is equal to, so again, we want the highest and the lowest. So the lowest was 34 and the highest is 79. And we just want to divide that by 2. Now, again, just to be safe, let's do it on the calculator. So again, do it in 2 steps. 34 plus 79 equals, and then divide it by 2. So 56.5. All right, and now for our other example, our lowest is definitely 0, but our highest is where? Well, looks like 38.1. So we had 0 plus 38.1 divided by 2, 19.05. Now remember, 2 decimal places is okay for our answer because our data had 1 decimal point. So just to formalize that rounding rule, let's take a look at the next part. It says, the round off rule for the mean, median, mid-range, carry 1 more decimal place than is present in the original set of values. So that's exactly what we said. So always just have that 1 extra level of accuracy with those calculations. Now mode's not included because mode is actually one of those values. So all right, so let's put it all together now in a single problem. So we want to find the mean, the median, the mode, and the mid-range for the given sample. Express the answers with the appropriate units of measurement. So again, units are important for this stuff. Don't leave them off. I mean, there's no units expressed here, but what does it say in the question? So, listed below are the gross amounts in millions of dollars earned in box office receipts for a recent movie released. The movie opened on a Wednesday, and the amounts are listed in order for the first 14 days of the movie's release. What is an explanation for the fact that the three highest amounts are the first, third, and fourth values listed? And then which measure of center best represents the quote-unquote center of the amounts and why? So that's an interesting question. So that gets into that analysis part, which is not a huge piece of this course, but it is going to be pieces that you're going to have to know how to think about. So, all right, let's start crunching. So if we want the mean, we got to add them all up. Oh boy. It's 58 plus 22 plus 27. So we had 229. So 229 divided by, and there was 14. So divided by 14 equals 16.357, blah, 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 blah. And if we round it properly, what would we round that to? Because our data has no decimal points, we definitely need to have a minimum of 1. Now, if you have more than 1, that's okay, but if you have less, then it's not. So always err on the side of putting more decimal places in your answer versus less. So let's round that to 16.4. And then let's put our units in. So the units are millions of dollars. So $16.4 million is the average. All right, now for the median, we got to put them in order. So 2 4s, 7, 8, 9, 9. 7, 8, 9, 9. Couple of 10s. 11. Looks like a 21. 22. 27, 29. And the 58. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we got all of them. All right, so because there's 14 and we're looking for the median, there should be 2 numbers in the middle. So let's work our way in. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it looks like the 2 10s are in the middle. So, well, we can average that out pretty quickly in our head. So 10 million bucks. All right. What about the mode? Well, here's one of those cases. Now we got some repetition in here. We got 2 4s, we got 2 9s, and 2 10s. So it looks like, and nothing happens 3 times in there, because that would, overwhelm the other cases. But in this case, though, we got 3 values that repeat the same number of times. Now, in some textbooks, it would say it's multimodal, but in this case, I would say that there's no mode. So because it repeats, because we have more than 2 modes, there's no mode. All right. Now, again, those can sometimes be a little funky in your brain as far as how that works. But I mean, if something happened 3 times, then there's no problem. But because you have 3 things or more that happen the same number of times, there's no mode. If it had just been the 4s and the 9s, we would have had 2 modes. But in this case we got 3. So there's no mode. All right, the mid-range, we got 58 and 4 are our max and min. So, whoops, not divided by 0. That's kind of hard to do, right? Let's divide that by 2. So 62 divided by 2 better be 31. Okay, so the calculation part of it's not anything drastic. It's tedious, but it's not drastic. So hopefully that part of it's pretty straightforward. The analysis questions can be a little bit trickier though. So let's look at the first one. What is an explanation for the fact that the three highest amounts are the first, third, and fourth values listed? So we got 58 is the first one, the third, and the fourth. So all those three are the highest. Why? So now you have to take into account the context of the question. What are all these numbers referring to? They're the box office earnings, box office receipts from a movie recently released. Well, hopefully the day it opens is going to kick butt as far as the sales. So that's the first day. So that's why that's big. But why does it skip the next one and go to the third? When did it open? Opened on a Wednesday. So Wednesday, Thursday, Friday. So the first weekend, of course, it's going to have a lot of box office sales on the weekend, first opening weekend. So opening day and first weekend should be the highest. All right, so that's kind of the idea. And you can phrase it however you want. I'm not going to get too crazy about that. Second question though, which measure of center best represents the center of the amounts and why? So now most people would say, well, the average, duh, that takes into account all the numbers and, so that should be the center, right? Well, look at your data. Does it look like there's any anomalies with your data? Anything that sticks out as being a little weird compared to the rest of them? Well, that 58 is quite a bit higher than the next highest one of 29. So that seems a little weird. That's kind of going to skew the data because of that outlier. So remember, if it's something that's far away from where the rest of them are, it's called an outlier. So 58 would be an outlier. I mean, the fours are kind of an outlier too, but you do have some other numbers that are in the single digits. So it's not too terrible. But that 58 is really kind of pulling the numbers higher than they actually are. So the mean's probably not a good representation for the center. What about the median? Well, the median says it's 10 million. Well, if we threw out that 58 for a second and looked at the rest of them, well, we got about 30s, we're in the 20s, we're in the 10s, and then teens, or in the single digits rather. So the median is actually kind of a better representation for that data because it doesn't take into account that outlier of 58. Now, the mode really doesn't help us at all, but the mid-range, again, the mid-range is skewed because of that outlier. That 58 is right there. So we got to be careful of those outliers. So in this case, the median is going to be the better choice for what represents the quote-unquote center. So the median, because it is unaffected by the outlier of 58. So, outlier of 58. All right, so hopefully that kind of makes sense how that works. So don't always go with the mean. The mean takes into account all the data, which is good, but outliers will skew it. So be careful. All right, we're going to keep going in the next video. So see you in a minute.